In this short clip, I really want to try to draw a conceptual framework that I hope each of you will end up with so that you can apply this logic, this little flow chart, this little framework to help you identify the type of analysis to run. There are three major statistical research designs. The first one is called descriptive. And descriptive statistics do exactly what they sound like. They describe a sample or population. So you include in descriptive statistics things like means, frequencies, percentages, percentiles, standard deviations, modes. The second research design is called causal comparative, with the key word being comparative. Causal comparative is a type of research design in which two or more means are compared for two or more groups. So when you've studied things like t-test, analysis of variance, those are causal comparative. The last type of research design is called correlational. And correlational is about the relationship or correlations between two or more variables. So if you ran bivariate correlations, if you ran multiple regressions of different types, partial correlations, they would fall here. So when I ask you questions or you see any type of problem to solve, there are key words that tell me, am I in a descriptive design, am I in a causal comparative, or am I in correlational? So I'll start with descriptive. How often? What is the frequency? What is the size? Those types of things tell me immediately I'm here. I'm in the descriptive design. When I go to causal comparative, really the key word is difference. Is there a difference between? Is there a difference between the height of males and females? So that key word difference is going to tell me I have some type of causal comparative statistic. Third, what's the relationship between, or is there a relationship between two variables? Is there a relationship between age and average speed driving? Correlational. That just gives you a big hint, and I'm going to talk about this more in a second, how you run these things in statistics with the SPSS specifically. But more importantly, what I need to get you to understand is, if I know I'm causal comparative, that's not enough to tell me which specific test. And so you say, I'm in causal comparative. How many groups do I have? Do I have one group, two groups, or two or more? If I have one group, the next thing I say is, how many variables do I have? So one example might be, the average income in the state of Kentucky is known to be $32,000 a year. That's my known value. And I ask the question, is there a difference in the average income of everyone that lives in Fayette County compared to that known value of $32,000? So I have one group, all the residents of Fayette County. I also have one variable, the annual income. So one group, one variable leads to what's called a one sample t-test. In my earlier example, I said, is there a difference between the height of male and females, for example? So again, I asked myself, how many groups do I have? Well, I have two, males and females. How many variables do I have? I have one variable, height. So that tells me I have two groups. You can't be in both. They are independent of one another. So I'm running an independent samples t-test. I have two groups, male or female, one variable, height. In the case of the one sample t-test, I had one group, all the people that lived in Fayette County, and one variable, their average income. Then I want to compare does the known value of $32,000 per year for all residents, working residents in the state. I go to the third leg here. And my question is, I'm going to Keeneland. And I want to know if a certain color of horse tends to be the fastest in 6 furlong races. And I'm specifically interested in gray horses, brown horses, and chestnut horses. In this particular case, I again ask myself the question, is there a difference in 6 furlong times between horses of different colors? Is there a difference? I'm in the causal comparative part of the flow chart. And I say, how many groups do I have? Well, in this particular case, I have 3. I have gray, brown, and chestnut horses. I have one variable. How fast are they? Their mean time in 6 furlong races. Because I have more than 2 groups that I'm comparing, and I'll explain this in far more detail when we go over it specifically, I run an ANOVA. An ANOVA allows me to compare more than 2 groups at one time. And we'll talk about the advantages of that again when we get to ANOVA. So, describe a sample. How fast, how tall, how much do they weigh, how often, anything that speaks to a frequency, a percentage, or something that could be described by me. I'm in the descriptive research design. Is there a difference? I'm in the causal comparative. A difference, I'm comparing 2 things, 2 means. If I have one sample and one variable, one sample t-test. If I have 2 independent samples like male and female, or I'm comparing Catholics to Protestants, I've got 2 independent samples, one variable, one dependent variable. How often do they go to church? 2 groups, one variable, independent samples, and 2 or more groups. An ANOVA, again, compares those means. That's my example of how fast is there a mean difference in the times in the 6 furlong races between horses of 3 different colors. That's causal comparative. Correlational is really, what's the relationship between? What's the relationship between average driving speed and age of the driver? 2 variables. And what's the relationship? 2 variables bivariate correlation. And that bi should key you in on only 2 variables. If I have more than 2 variables, it's called a multiple regression, multiple keyword. And that would be something like this. I want to know, I'll go back to my Keeneland example, which horse I think is going to win. And I know that horse's jockey has a certain winning percentage, the trainer has a certain winning percentage, the owner has a certain winning percentage. There are times in how quickly they've run races in the past. What a multiple regression does is say, if I know all those things about this horse past, can I predict how well they're going to do in the future? So more variables trying to predict one dependent variable. If I just have the relationship between 2 variables, it's a bivariate correlation. If I'm trying to predict one variable from many known variables, it's called a regression. So let's say you're on an admissions committee at KCTCS, and you want to decide who is going to do well once they're enrolled in your school. Yes or no, you're going to be able to retain them. So your dependent variable, also called a criterion variable in the case of regression, is retention. And you know their ACT score, their high school GPA, and their teacher recommendations. Again, what that regression says is, if you know those three things, a kid's high school GPA, their ACT score, and their teacher's recommendation, can you predict better than chance alone whether that student will be retained or not at your school? And obviously with those three variables, you most likely could. So that would be a regression. So what I want you to do when I go through these particular problems is start with the questions and keywords that clue you into these three types of research designs, and then start asking yourself, how many variables, how many groups, and you should at least be able to get to this point. I'm going to add one more little question, but I don't think you've covered these particular analysis, and so I'll add it later. But the particular question is, are you controlling for something? And when you control for other variables that might affect your dependent variable, those are called covariates. They vary with your dependent variable, and they may also vary with the two groups you're comparing. So you don't want to go into two types of schools. We'll use K-12 schools, a very affluent one, and one that has almost all students eligible for free or reduced lunch, and then compare their test scores and say the one with all the affluent students is better because their test scores are higher. You want to compare apples to apples. And so what you do is you say these two schools differ in a certain way that can also affect test scores. And that way is called differences in the number of students eligible for free or reduced lunch or low income students. So then when you make the comparison, you say, I'm going to compare these two schools' test scores, but I'm going to make sure any difference is not due simply to the students they serve. It's more about how they teach and what the school does. And it's a lot more apples to apples, if you will. So those control variables take me into, from the ANOVA to an ANCOVA, with that C standing for covariate. And again, a covariate is simply something that differs between the two groups and also has an effect on your dependent variables. Poverty, differences between those two types of schools. It affects test scores. We want to make sure that when we compare those two schools, we don't give the school serving all affluent students an advantage.